have already introduced to you what is a set. Okay, so now let's look at how do we describe a set. Okay, so there are two ways to describe a set. There are times whereby in exam and tests and all that, right? They will give you the elements. Okay, then after they ask you to describe in a certain way. So one way is to describe in words. So for example, it's like what we have already previously seen. Okay. So if you write it out like that, right, it will actually mean that we are describing the particular set in words. So if I write it in set notation later on, so another way to describe it is by listing. Oh yeah.
Hurry, get in and close the door. Get in and close the door. Close the door, hurry.
要讲关门。
Properly. Aircon.
Or even my head. Okay, so if you want to write this in terms of listing all the elements, okay, that will actually be 2, 4, 6, 8. Right, then we write in bracket signs. Okay, sorry, curly brackets. Okay, then after equal sign and then after capital letter S. And then another way which I have not yet introduced, which is by set notation. Okay, so set notation would be taking the set to be S, you will put equal sign, curly bracket as well. Okay, X represents the elements found in the set. Then 2 dots representing is such that X is a positive even integer less than 10. Okay, so this is an alternative notation, but rarely we see it being used now. Okay. How we read it, okay? That X is an element such that X is a positive even integer less than 10. Okay? Of course, at this point you will find that this sort of notation seem very wordy. Okay, why not I just use this or this? Okay? Of course, for now, this definitely isn't very helpful. Okay? First, if you pursue maths further, you will learn more notations. Okay? So you can actually put this into notation form. Okay? But for now, we will not introduce those notations. Any questions so far? Okay, let's look at practice now 1. For part 1, they ask you to list all the elements in C and D in set notation. Okay, this can be considered set notation as well. Alright, but they ask you to list all the elements, that's the instruction. Okay, so what they want is actually this part here. Okay, so how would we list out all the elements? What are the elements in C? 11, 12, 14, okay, all the way to 17, right? Please do not put dot. Okay, try to list them out. Of course, in exam we will not ask you to list out from 1 to 100. What about D? It will be 10 to 17, right? Part 2 asks whether these two sets contain the same elements. Clearly, it is not, because there is extra 10 over here. Question on whether the two sets have contain the same elements brings us to the part of equal sets, where equal sets refers to two sets containing exactly the same elements. So in such cases, we write it as A equals to B. It need not be the same order, so I can have A to be maybe 1, 2, 3, 4. B to be 3, 2, 1, 4. Okay, they will still remain as equal sets. And since these are equal sets, clearly we also can tell that the number of elements will have to be the same as well. That will be implied. Next, we take a look at empty sets. Okay, so if looking at these three sets over here, I have A, whereby the elements are 0, 1, 2. Okay, B contains the element 0, and C has nothing inside. Okay, C is what we call an empty set, whereby there are no elements inside it. Sometimes we also call it a null set. We could write the empty set in such a notation, C equals to curly brackets and then nothing inside. Or sometimes I could also write C is equals to this notation. Okay, this is phi EHI That's how it's being pronounced. PHI. Yes. So phi sin PHI. I think it's a Greek letter. Okay, so you need to recognize that this could be used interchangeably. Okay. Is B an empty set? B is not an empty set. Having a 0 inside, 0 is the element. So B is not an empty set. So you need to differentiate these two. Just to throw something out of this part that we're looking at, since we're looking at empty set. What if I have a set that looks like this? Is D an empty set?
No.
Huh? No. How many of you think that D is an empty set? Who thinks that D is not an empty set? Okay, so D is not an empty set because it is a set containing an empty set. So the empty set is an element of that set.
So it's like C lah.
It's set.
So
D is not empty.
It's a set containing an empty set. Yeah.
Yes, it is a set containing an empty set.
So the empty set is like the element already.
Yes.
Yeah. So imagine C is empty, right? So it will be D. C is an element of
Okay.
C
you will maybe know more about it further. Okay. Now let's look at practice now 2.
So I call it 5.
Okay. We have P whereby it is a set where X is a positive where X is an element is such that X is a positive integer less than 1. Okay, then after Q is a set that contains 0. Okay, part 1, these are the elements of P in set notation. Okay, so how will you describe P? What is element in P?
Nothing.
There's no element, right? Because just now we have addressed, okay, that 0 is neither positive nor negative. Okay, although it is an integer. Okay, so therefore it does not fit in this. So P is actually an empty set. Okay, so if you need to describe it in set notation by listing elements, you can write it in this way, or you can write this. Okay, so is P and Q equal set?
No.
No, huh? Okay, Q contains elements. exercise 1A. Right? Let's look at whether they are true or false. So first one, how do we read that? C is not an element of the set CAR. So is that true or false? False. Okay, so in this case the reason is simple because C is an element. How about part 2? It is false, okay, because this is a word, CAR, or if you look at it algebraic sense, this is C times A times R, okay. About part 3? False. Okay, why?
There's no set. Set C.
Okay, because this is a set, there is no set in it. The elements in this set does not contain a set.